Hello students, good afternoon everyone. Welcome to the physics class. Welcome to the physics session guys, the paper discussion session. Inform the others, everyone to join in this session, in this link. If anyone has joined the Zoom link, inform them to join here. Inform them to join here. If any of your friends have joined in Zoom link, inform them to join here. Quickly inform them to join here. If any of your friends have joined in Zoom link, inform them to join here. Yes, very good afternoon guys. Yes guys, I will give you one more minute, just two more minutes. Inform your friends guys, inform your friends. Still many of your friends, it seems they have joined in Zoom link. Inform them to join here. I think they have not observed this message in the WhatsApp group. Someone inform them. Yes guys, still, so let me just seems still many of them has not got the information. Let me just join that Zoom and the invite once, just a minute. Yes guys, so try to inform if you have any just possibility, try to inform them. Just a second guys, just a second, be in line. For the host to start the meeting. So it seems the host has not started the meeting, it's showing still. Okay. Yes guys, Okay, everyone, fine. So, even in Zoom, just it seems the meeting has not yet started. That meeting also, I think that for the others there is no possibility of joining there. So let them join. Let us go ahead. So and as already is about to 3:10. So let us discuss as many questions as possible from the track 2 part. And if any questions left over, I hope you are understanding. Are you getting my voice, guys? Just drop me a message. Voice is audible or not? If you are getting my voice, just drop me a message that voice is audible. Just drop me a message that voice is audible. Yes, guys. Drop me a message that voice is audible. Quickly, now, quickly. Hello, everyone. This is someone. Respond or not? Respond, someone. Are you getting my voice? Are you getting them? Are you getting my voice? Yes. Okay, guys. Okay, fine. Right, right. Fine. Thank you. Thanks for the response. Yes, guys. Let us go ahead. Track two part. So first, let us see the first question. It is given that. Let me. It will minimize this. Here only we will see the discussion part also. I will explain here itself. Right. A, a thin double convex lens is cut into two equal pieces A and B by a plane containing principal axis. This piece B, this piece B is further cut into two more pieces C and D by another plane perpendicular to the principal axis. If the focal power of the original lens is P, then those of A and C are. So if you draw a pictorial representation for this, then it will be more clear for you guys. See here, yeah. See here, so we have a double convex lens. So a double convex lens. So we have a double convex lens is a double convex lens having focal length f and focal power p. Now this is cut into two equal pieces A and B by a plane containing principal axis. So if you take a paper and if you pass the paper will be taken as a plane, if you pass the paper through this line called principal axis, that will be called as a plane passing through principal axis. Through this plane, if you cut this into two equal pieces, you will get two pieces like this. One piece, one piece like this, and another piece like this, another piece like this, two equal pieces. Yes. So we have already discussed that if here the two pieces are named as A and B. So here as the surfaces are same, radii of curvature remains the same, so the focal length of these pieces will be same, and hence power also will remains same for these two pieces. Now the piece B, this piece B is further what is that, cut into two equal pieces through a plane perpendicular to principal axis. This is principal axis, perpendicular to this is this one, into two equal pieces. So we'll get pieces C and D. So now this C and D will be looks like this. So this is equivalent to this, and this is equivalent to this. Here this piece will be as it is, we are not touching this. This will become again two more pieces. So one a plane and a curved surface kind of like this, right? A curved surface like this, and another one is a plane and a curved surface like this. So because here this becomes a plane surface and this becomes a plane surface, their focal lengths will become exactly half of the what do you call focal lengths of this, got it? So, and hence their powers also will, sorry, the focal lengths will become double, focal lengths will become double. So this is a C and this is D, its focal length will become 2 times that of the initial one, 2f. It will also become 2f, and hence focal power of this will become half of the initial power, half of the initial power. As we know, power is inversely proportional to focal length. Power is inversely proportional to focal length. When focal length doubles, power will become half. Now, which is in the question, if that is the case, then the powers of A and C are, which is A, this is A, this is B. So this is A. Power A is not touched. So power of A will become, same as that of the initial power P, and this is C and D. For power of C becomes P by 2. So this is how we have to understand this kind of questions. Have a note of this. Have a note of this. Then, right guys, right. Next, so let us see quickly. Next question number 3. So for this, the option should be P and P by 2. Next one. A convex lens of power plus 6D, D means diopter, it is unit of power, plus 6 diopter is placed in contact with a concave lens of power minus 4D. The nature and focal length of the combination is. So how to understand this? You have to just observe here. You have to observe here. Question number 3. So we have a convex lens and this is having a power of this lens, let us say it is P1, it is equal to 6 diopter, and it is kept in contact with, this is kept in contact with, this is kept in contact with a concave lens, this is kept in contact with a concave lens, okay. Now the concave lens, let us say our focal length is f2 and hence power is p2 is equal to minus 4 diopters. Then the nature and focal length of the combination is, so these two are kept in contact. So power of this combined lens will be expressed as P is equal to P1 plus P2. This so effective power. So it is equal to P1 is 6, P2 is minus 4. So effective power is P is equal to 2 diopters. It is a positive power. So and hence focal length. What should be the focal length? Focal length of the effective lens or combined lens is 1 by 1 by f is equal to P. So and hence P f is equal to 1 by P. It is equal to 1 by 2 is equal to 0.5 meters. But options are given in if you see here, options of focal lengths are given in centimeters. So you can write it as f is equal to 0.5 meter can be expressed as 50 centimeters. So because the focal length and the power and hence focal lengths are positive, the entire combination will behave like a positive, what is it, positive focal length lens, that is converging lens. So the combination will behave like a converging lens of focal length this, converging lens or convex lens of focal length this. So what will be the answer? So option 2, convex lens of focal length 50 centimeters. Next question number, let us see fifth one, question number 5. So it is given that a ray of light is incident at 60 degree on a prism of refractive index 30 degrees, of refracting angle, 30 degrees. Refracting angle means angle of prism, okay. The emerging ray is at an angle of 30 degrees. Emerging ray is at an angle of 30 degrees with the incident ray. With the incident ray, this is very important guys, with the incident ray, not with the normal, keep in mind that. So the value of refractive index of the prism is, so what is given here, try to note down little carefully. Right, question number 5. So what is given here? A ray of light incident at 60 degree on a prism. At 60 degree means angle of incidence can be taken with the normal. So angle of incidence I is equal to 60 degree on the prism. Let us consider this is a prism This is a prism, so a ray of light is incidenting, so that with respect to the normal, this is angle of incidence I, and hence it is refracted, and then here it is emerging out. So that if this is incident ray direction, so it is also given that refracting angle of prism is also called as angle of prism. It is given as A is equal to 30 degrees. Refracting angle of prism or angle of prism is 30 degrees, and the emerging ray is at an angle of 30 with incident ray. This is incident ray, this is emergent ray. If you extend this back, this angle is called as angle of deviation. So this angle is called as a deviation angle. It is equal to how much? 30 degrees is given. Then the value of refractive index of the value of refractive index of the prism is what you are asked to find. Right, how to find this? See here, how to find this? Guys, what is the problem? Are you not getting the voice clearly or board clearly? Then why many people have not joined? Sir, if anyone is there, sir, Shaktivel sir, or Florence madam, or someone is the in charge, please look into this once. Why this much strength? This is already the revised part, of course. You have to just go through this guys once again. Right, fine. So let us see here. So we are asked to find what? Refractive index. So what is the relation between this given data? You should have an idea that here this is angle of incidence, angle of prism is given, and we know that um, if this is R1, this is R2. Can let us maximize. This is R1, this will be R2. You can you know that delta delta is equal to I1 plus I2 minus A. This is I1, angle of emergency is not given, delta is given, I1 is given, A is given. Can you find I2, angle of emergence? Angle of emergence. Then, by making use of this, how can you find what is the refractive index? So you have to just substitute these values that from this we can say as delta is how much? 30, which is equal to I1 is 60 plus I2 we don't know, minus A is given as 30. So if this is minus 30, 60 minus 30 is 30. 30 is equal to 30 plus I2. I2 is equal to 30 minus 30, so I2 is equal to 0. 30 is equal to sorry, I2 is equal to 0. 0 means it is supposed to be passing through the normal. It is supposed to be passing through the normal. The angle of angle with respect to normal is 0. Usually, you can call, then if I is 0 means you can call such a kind of incidence as normal incidence. If I is 0, then the corresponding R also will be equal to 0. You can say R2 is also will be equal to 0. And here, you have to, just you have to, yeah, corresponding R2 is 0 means you should also remember one simple relation here, that is R1 plus R2 is equal to A, and as R2 is 0 from this discussion we can say that as R1 plus R2 is A, and as R2 is 0, A is how much? 30. We can also say R1 is equal to 30. And R1 is this and I is this. At this point, if you apply Snell's law, then you can write mu is equal to here sin I by sin R1 is equal to I is 60. So sin 60 by sin R1 is 30. Sin 60 is root 3 by 2. Sin 30 is 1 by 2. So we'll get mu is equal to what? Mu is equal to root 3. Is there any such option for fifth one? For fifth question, root 3. Yes, this is the option, correct option, root 3. Fifth one. Right. Then let us work out few questions here only. Yep. Okay, guys. Next. So question number 5 done. Next, this one, let us see. A prism of refracting angle 30 degree is made of a material of refractive index 1.652. Find the angle of minimum deviation. What is that? A prism of refracting angle 3 degrees. Refracting angle. What is refracting angle? Means angle of prism. So question number 7. Let us do the question number 7 here. So what is this? A prism of refracting angle. Refracting angle is angle of prism is equal to 3 degrees. 3 degrees is made of a material of refractive index mu is equal to 1.652. Find the angle of minimum deviation. Delta minimum is equal to what? So here angle of prism is given as 3 degrees. So such kind of prisms are called thin prisms. For thin prisms, we have considered already, I have discussed that conditions of minimum deviations are applicable here, and then we have obtained one relation that delta is equal to mu minus 1 into a. For thin prisms, deviation is given as mu minus 1 into a. Here mu is given as 1.652 minus 1 into a is 3 degrees. So delta angle of deviation, minimum deviation, is equal to 1.652 minus 1 becomes 0.652 into 3. So 3 to 6, 3 5s 15, 3. What is this? This will be uh, yeah, 3 6 say 18 plus 1 9. Is this, is it 9? 19. 18 plus 1 19. So three decimals you have to put for three decimal, we will be having three decimals here. So the angle of minimum deviation should be 1.956. 1.956 degree will be the angle of deviation or minimum deviation. This is how we have to deal with this kind of questions. Note down this. Then let us go ahead little quickly. Next question. Question number, yeah, question number 7 done. So it is 1.956. Then ninth one. Ninth one, it is given that a glass prism deviates the red and blue rays. A glass prism deviates red and blue rays. Yes, guys. Yes, no any messages after that? So okay, voice is audible. Okay, okay, fine. So there is everything is fine, I think, right? You're getting clear, right, guys? Right. So just if anything, if you are getting any issues, just you can drop a message. You frequently just I used to observe this messages maybe in the mobile also. If I didn't observe within a minute, try to give me a call, guys. Okay, right. Next question number 9. So it is given that a glass prism deviates the red and blue rays through 10 degree and 12 degree respectively. A glass prism deviates red and blue rays, red and blue. So the angle of deviation for red is equal to 10 degree, 10 only, 10 degree, and blue rays for angle of deviation for blue is equal to 12 degree. Okay, and a second prism, this is for first prism, this is, let us say, for prism A. There is another prism B, you can say, for second prism of equal angle, that is angle of prism same, deviates the same colors, what is that, red and blue colors through, for this is one, for the first prism, deviations for red and blue of first prism, deviations of red of second prism is given by 8 degree, and that For blue ray is given by 10 degree respectively. For another prism, second prism you can say, first prism and second prism. Their dispersive powers are in the ratio. Their dispersive powers are in the ratio. What is the ratio of dispersive powers of those two prisms? Dispersive power of the first prism by dispersive power of the second prism. Dispersive power is nothing but ratio between angular dispersion by mean deviation by angular dispersion by mean deviation. For the first one, angular dispersion is difference between the angles of deviations of this. So you can write it as delta R1 minus delta R2. Difference between them are delta of blue B1 minus delta R1 divided by mean deviation. Mean deviation means delta B1 plus delta R1 divided by 2 is the dispersive power of the first prism. That of the second prism can be expressed as delta of B2 minus delta of R2 divided by the mean deviation. That mean deviation, let us consider here, delta of B2 plus delta of R2 divided by 2. This value should be substitute. Delta of B1 is 12, R1 10, so 12 minus 10, 2 divided by B1 plus delta B1 plus delta R1 by 2, that is 12 plus 10, 22 by 2. 22 by 2 is 11. Directly I am writing the values. And similarly for this, B2 minus R2, 10 minus 8 is 2. Then average of these values, what is that? 10 plus 8 by 2, 18 by 2 is 9. So 2 gets cancelled. You get this is equal to 9 by 11 is the ratio of dispersive powers of these two prisms. 9 by 11 or 9 is to 11. 9 is to 11. So which is the right one? Yes, option 9 is to 11. 2 is the right one. Next, the next question. Let us see here. Question number. I hope it is visible for you guys. I hope you are getting clearly. Next, question number 11. Question number 11. So what is given here? It is given that the refractive indices of yes guys, the refractive indices of violet and red light are 1.54 and 1.52 respectively. 1.54 and 1.52 respectively. If the angle of prism is 10 degree, then the angular dispersion is, so what is that? The refractive indices of violet and red color light. So violet light, refractive index, not a deviation, refractive index. The refractive index of the refractive index symbol is, you can write it as mu or n, any symbol. Refractive index of violet light, mu v, is equal to 1.54, and refractive index mu of red color light is 1.52 respectively. If the angle of the prism A is equal to 10 degree, so it is a thin prism, 10 degree, then the angular dispersion is what? Angular dispersion is delta is equal to what? Can say it as angular dispersion is, you can write it as dispersive power is different, angular dispersion is theta. Theta are the different symbols you can use. Angular dispersion, you can write clearly angular dispersion in words. Then angular dispersion, theta is equal to what? You know, angular dispersion is difference between the deviations. Dispersive power is ratio between angular dispersion and mean deviation. So you have to remember this. So here you can write angular dispersion theta is equal to difference between deviations. As for thin prisms, it is nothing but mu minus 1 into a. On simplifying this, as it is Angular dispersion is difference between the deviations of this the two given colors mu v minus mu r. And simplifying this, we can write it as delta v minus delta r can be expressed as mu v minus mu r into a. How will you get this? Because delta is equal to mu minus 1 into a. Mu v is equal to delta v is equal to mu v minus 1 into a, and delta r is equal to mu r minus 1 into a. On simplifying this, we will get this relation. Here we are asked to find angular dispersion by giving these values. So direct substitution. So mu v minus mu r. Mu v is 1.54, mu r is this. So 1.54 minus 1.5 is 0.02. Directly I am writing the value. Into a is 10. So it is equal to 0.2 degree. So therefore theta is equal to 0.2 degree. That's it. Got it? Next. So which option is the right one? For 11th one, second option. Second option is the right one. Next, for 13th one, let us see 13th one. Question number 13. So what is given here? What is given here? It is given that a concave lens of glass of refractive index 1.5, a concave lens of glass, a concave lens. So a concave lens made of glass of refractive index mu is equal to 1.5 has both surfaces same radius of curvature. So R and R1 equal to R2 equal to R, have both surfaces have same radius of curvature R. On immersion in a medium of refractive index 1.75, it will behave as, it is made of glass having refractive index of this. When it is immersed in a medium, so that refractive index of the medium is 1.75, then it behaves as what kind of lens is the question. To understand this, number of times, number of different kinds of questions also have worked based on this kind of this method of questions. If yeah, still if you have any confusion, listen carefully. If you have an idea already, you can just follow, you can work out on your own and try yourself and tell me the and drop a message, drop the answer in the message. So first, when the lens is in air, then focal length will be taken as by, according to what is that Lensmaker's formula. Focal length of this lens when it is in air is given as 1 by f is equal to mu of the medium with respect to air minus 1 into 1 by r1 minus 1 by r2. For this it is negative, for this it is positive, so equal values will get 2. Negative value of course will get 2 by r you will get. This is when it is in air, focal length of the lens in air. Whereas if it is in a medium, then if in a medium, focal length of this when it is in a medium is given by refractive index of the glass with respect to medium minus 1 into, of course, radii of curvature at same, so you can take it as minus 2 by r. Only value if you want, you can take it as because the focal length of the convex concave lens will be negative, so we'll get negative here. So negative will get here, negative. This negative sign tells about its nature. Now, but in this case, how it behaves is, if you take this as equation 2, these two equations we can rewrite them as 1 by 2. If you take 1 by 2 gives you 1 by FA by 1 by FM. So 1 by FM goes to numerator. So you have to find out what is focal length of the lens, this concave lens in a medium. So with the sign, then depending on the sign, you can say if the sign is positive, you can say this in a medium behaves like a convex lens. If it is negative, then you have to say that it will behave like a concave lens in the medium. So to arrive into that conclusion, you have to find this. It is equal to, that is what, 1 by 2 is equal to this by this, mu of glass minus 1. Mu of glass is given as 1.5, so 1.5 minus 1 is 0.5. and directly I am substituting the values here by this. You can write it as mu g by mu m. mu g by mu m minus 1 into 2 by r by 2 by r gets cancelled, minus 2 by r minus 2 by r. Here we can write minus 2 by r by minus 2 by r gets cancelled. So overall you will get focal length of this lens in a medium is equal to 0.5, can be expressed as 1 by 2 or directly can 0.5 also can keep it, into 1 divided by this into focal length of this lens in a medium. So overall you will get positive and negative sign. Let us see. So mu of glass with respect to air is 1.5, is, what is that, 1.5, right? 1.5, 1.5 divided by that medium is 1.75, so we can say minus 1.75 divided by 1.75. Got it? So into focal length in air, focal length of that lens in a medium is equal to. So here this gives you what kind of value? So it gives some value. So this you have to find out carefully. So on simplifying this, you'll get, what is this, concave lens, right, in a medium. Yeah. So it is equal to uh, 1 by 2 into, this gives you negative value, focal length of the lens in air. So here it is 1 by 2 into 1.5 minus 1.75 gives negative value. So you'll get some negative value. You're getting this? You get some negative value. So exactly the value also, if you want to, by looking into the observations, you have to simplify it, guys. It is question number 13. You are asked to find the value also, just only the nature you are asked to find. Question number 13, right? We're asked to find the value as well. So we have to find this, then simplifications also have to do. 1.5 minus 1.775 or 1.75 minus 1.5 is 5.25. So we'll get 0.25 here, negative value of. So we have to write it as 1 by 0.25 divided by 1.75. So into FA. So this 1.75 goes to numerator, and on simplifying this you will get or you can write it as 25 by 175. So it is equal to 1 by 2 into 175 by 25 into focal length of the concave lens. So this 25 threes and 25 fours, 7 times it will goes, 7 by 2 times focal length of the concave lens will get. What is that? Focal length of the lens in a medium. So it is focal length of the concave lens will be in air medium will be negative. That you have to keep in mind here. It will be, so here negative sign is there, guys. Negative sign is there. You have to take this negative sign into FA. So this is negative, this is also negative. Negative into negative will give positive value. Positive value will get. So at the end you will get F, focal length of the lens in a medium is equal to positive value. How much is that? Positive, that is equal to 7 by 2 is 3.5. So you have to take it as, actually, for a what is that, a concave lens is equal to directly can substitute, you can, of course you can find out this, what is that, this is nothing but, for a concave lens here 1 by FA is equal to, here I have taken, right, from 1 implies, here write down F is equal to 1.5 minus 1 is 0.5, that is 1 by 2 into you'll get minus 2 by r, minus 2 by r, 2 gets cancelled, you get minus 1 by r is FA, minus 1 by r. So if we're substituting this, you get minus 7 by 2 into minus 1 by r. So minus minus gets becomes positive. So you get 7 by 2. What is that? By r. 1 by f is this, minus 1 by r. FA is equal to FA is equal to minus r. So you have to take it as minus r. Minus minus gets cancelled, you get r. So it is plus 3.5 r. So FM focal length of this lens in a medium is plus 3.5 r. So it will behave like a converging lens of focal length. This question number 13. Converging lens behaves like a converging lens. Converging lens of focal length 3.5 r. Convergent. Convergent lens of this. No, 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 no. So first option is right. Right. So that's it. So this is how we have to work out. Next question number 14. So not 14, 15. Let us say 15. A thin biconvex lens. A thin biconvex lens. Right, guys. Yeah. A thin. What is given here? 15th one. A thin biconvex lens of focal length 20 centimeters is made of refractive index 1.5 when it is dipped in a liquid of refractive index 9 by 8 it acts as. So how to understand this? So what is given and what you are asked to find? The same procedure there also you have to apply. What is that? When a biconvex lens of focal length f is given and its refractive index is also given. So by convex lens, we have positive focal length. It acts as a converging lens when it is in air medium. When it is dipped in a liquid of refractive index, if you find what is focal length, depending on its nature, you have to say whether it will behave like a concave or convex, and with the value you have to select your final answer. Same procedure you have to use, and you have to select here. Let us work out here itself. Then the side question number 14. Question number 14, it is given that, or can we do somewhere here, this side, can we do somewhere here, if it is visible for you, I will do here, question number 14, yeah, it is not 14, 15. It is given that a thin biconvex lens of focal length 20 centimeters, f is equal to 20 centimeters means plus 20 centimeters, it is a biconvex lens, plus 20 centimeters, is made of glass of refractive index mu of glass is equal to 1.5, and when it is dipped in a liquid of refractive index of the liquid is equal to 9 by 8, then what will be the focal length of the lens in the liquid? Focal length of the lens in air is this, focal length of the lens in the liquid is what? If you find, then you will get it. So for finding this, you have to use Lensmaker's formula. So by using Lensmaker's formula, I can write 1 by Fa is equal to mu of G minus 1 into, it is what? It is what kind of lens it is? It is a thin biconvex lens. So let us write it as 1 by R1 minus 1 by R2. The same lens we are dipping in a liquid. So in that liquid, the focal length is 1 by Fl is equal to mu of the glass with respect to liquid minus 1 into 1 by R1 minus 1 by R2. Radii of curvature will not change. So if you take this is 1 and 2, and if you take the ratios of this, 1 by 2 gives, this implies 1 by Fa by 1 by Fl gives you Fl is equal to Fa into mu. Let us do here little clearly, just while doing the calculations, to avoid the confusion. Fl by Fa is equal to mu g minus 1, mu g is 1.5 minus 1 is 0.5 divided by mu g by mu l. Yeah, mu g by mu l, mu g, I can also write this as 3 by 2, 1.5 is nothing but 3 by 2, right? So we can write it as mu g, it is mu g by mu l minus 1 into 1 by r1 minus 1 by r2. Here 1 by r1 minus 1 by r2 gets cancelled, nothing will be here. This you have to understand clearly. Next, this is equal to 1.5 can be taken as 1 by 2 and into 1 divided by mu g is 3 by 2, 3 by 2 divided by mu l. Mu l is 9 by 8, 9 by 8 minus 1. This you have to take carefully. So 3 3s, 2 4s, 4 by 3 minus 1 you will get. So then this further can be expressed as 1 by 2 into 1 by 4 by 3 minus 1, 4 minus 3 by 3. So 4 minus 3 is 1 by 3. So it becomes 3 by 2. So we'll get Fl is equal to 3 by 2 into Fa, that is focal length in air medium. It is given as 20 centimeters, plus or minus. We have got all positive signs only. So it will be Fl, focal length of this lens in the medium liquid is positive value of 3 by 2 means 1.5 into 20. What is this? 15 into 2 is 30 centimeters plus 30 centimeters plus 30 centimeters. Right. So which option is right? Question number 15. Question number 15. It acts like a convex lens of focal length 30 centimeters. So option 1. Option 1. That's it. So this is how you have to work out this kind of questions. Next, let us see 17th one. So what is given here? It is based on what? Prism. So the angle of minimum deviation measured with a prism is 30 degrees. Angle of minimum deviation measured with a prism is 30 degrees. Minimum deviation is 30 degrees, and angle of prism is 60 degrees. Then refractive index of the prism material is 17th one. Let us try to work out the 17th question. Right? Can we do here? So guys, I hope while working, I guess you have followed this. That was the font size was okay. Now just for working purpose, just I am minimizing the screen and writing. So question number 17. Let us work out now. Question number 17. So what is this? What is this? So it is given that the angle of minimum deviation of the prism is 30. Minimum deviation delta minimum is equal to 30, and the angle of the prism is 60. Angle of the prism is 60. Then refractive index of the material of the prism is what? Mu is equal to what? So to understand this, it is a simple relation of use. What is the formula for refractive index of material of a prism? We know that as mu is equal to sine A plus delta minimum by 2 divided by sine A by 2. By using this, you can write sine A is 60 plus 30 by 2 divided by sine A by 2. A is 60 by 2 is directly you can write, of course, you can write in the next step. So this is equal to what? Of course, this is the previous one. So the 60 plus 30, 90 by 2 is sin 45. Sin 45 is 1 by root 2. Okay, sin 60 by 30, sin 30 is 1 by 2. So a 2 by root 2, 2 can be expressed as root 2 into root 2. So it will be root 2. So therefore mu is equal to root 2. So this is how you have to work on this. Next, question number 17 done, over. Next, 19th one. 19th one. Let us see what is the question. Let me maximize a little bit. 19th one. So what is given here in 19th? It is given that when light rays are incident on a prism at an angle of 45 degree, guys, just why I'm doing this here in the YouTube is if you can go through this once again, you can go through these explanations once again if you have any confusions. That's why I am doing this. So if we need at any time to go through the explanation, you can go back and you can listen it, or if you want, you can pause and you can copy it and you can go through. Okay, right? Okay, guys, there are still few more questions. Let me, yeah, so let me just take just a few minutes and let us finish this, at least this question, then I can wind up. The remaining questions we'll discuss in the study hour. So those are having the doubts in the remaining questions, you can don't skip the study hour session. We'll discuss those questions in the study hour. Next, let us go through this question now. So 19th one. What is given here? It is given that when light rays are incident on a prism, at an angle of 45 degree, the minimum deviation is obtained. Minimum deviation is obtained. That means a condition is given here. Minimum deviation means all relations related to minimum deviation can be applied. What is that? I1 equal to I2, R1 equal to R2, or I equal to E, whatever it is. All these relations can be applied here. If the refractive index of the material of the prism is root 2, then angle of prism will be. So how to work out this? What is given first? When light rays are incident on the prism at an angle of 45, means angle of incidence is given. Question number 19. Question number 19. Question number 19. Right. So angle of incidence is given. I is equal to 45 degree. 45 degree. Angle of incidence is 45, and minimum deviation is obtained, means you have to say here itself I can say at this angle we are getting minimum deviation. So I is equal to E, angle of emergence. and also R1 is equal to R2. In R1, when you say R1 equal to R2, you have to also recollect back that A is equal to R1 plus R2. When R1 equal to R2, then you can write 2R1. This is equal to R1. This is equal to R2. Also can write. Depending on some requirements, we have to make use of this also. And what else is given here is and the refractive index of the material is root 2. Then angle of prism will be refractive index mu is equal to root 2. Then angle of prism is equal to what? So here from this we can say angle of prism is equal to R1, R2, R2. Okay, so by applying any of these relations you can find out, say if you have a prism, if a light ray incidents somewhere here, if this is angle of incidence I, and here it refracts, so that this will be the angle of refraction at this surface. You can take it as R1. So if you apply Snell's law at this point, if you say this is point P, you can write, so from Snell's law, sin I1, you can, if you take it as I1, sin I1 by sin R1 is equal to mu2 by mu1, that is equal to mu. So from this you can say sin I1 is 45, sin 45 degree by sin R1 we don't know, sin R1 is equal to mu is root 2. Now this further can be expressed as sin R1, if you cross multiply here, you bring it sin R1 here and root 2 bring it here, and sin 45 is 1 by root 2, so you can write it as 1 by root 2 into 1 by root 2. You bring this here, this becomes by root 2, then you can get this is equal to sin R1. So 1 by root 2 into 1 by root 2 becomes 1 by 2, sin R1 is equal to, this implies sin R1 is equal to 1 by 2. So that implies R1 is equal to sin inverse of 1 by 2 is 30 degree. So when you know R1 is 30 degree, from this relation you can say A is equal to 2R1. This implies A is equal to 2R1 is equal to 2 into 30 is 60 degrees. So angle of prism will be 60. This is how we can calculate angle of prism. So what will be angle of prism then? 60. So which option is right for this 19th one? 60, option 3. So option 3. Next, can we work out one more question here? Yes, guys, can we work out one more, a few more questions? At least one more question? Or can we continue in the study hour? Drop me a message. Drop me a message. If it is okay, just I can continue for a few more minutes. Yes, guys. Yeah, I think is okay. Okay, I think no one has opposed me, so I can continue for a few more minutes. So let us discuss. Let us discuss next question number 21. 19 over 20 will be the other one. Then 21. Next alternate one. So question number 21. So what is given here in the question number 21? So question number 21. Question number 21. So it is given that in this, if the refractive index of material of equilateral prism is root 3, then angle of minimum deviation of the prism is refractive index of material of equilateral. Equilateral means what? All angles will be same, that means 60 degrees. Angle of prism is given indirectly, it is 60. If angle of prism is 60 and refractive index of that is root 3, angle of minimum deviation of that will be, so how to get that? You see here, just by you see here, this kind of relation you have to make use in this case. So what is given here? Angle of, sorry, it is equilateral prism, given that for equilateral prism, for equilateral equilateral prism, equilateral means we have to understand that all the sum of the all three angles will be equal to are equal. So it is equal to the sum of these angles will be 180. That means angle of prism A should be equal to 60. For equilateral prism, A is equal to 60, and this equilateral prism is having refractive index mu is equal to root 3. Is it root 3 only? Is it root 3 only? Yeah, root 3. Then angle of minimum deviation of the prism is what? Then angle of minimum deviation of the prism is what is the question. So we can use the relation here. We can use the relation mu is equal to sine A plus dm divided by 2 divided by sine A by 2. So here we have given simplifies mu is given as root 3. Root 3 is equal to sine of A is 60 plus minimum deviation angle by 2 divided by sine A by 2. A is 60, so 60 by 2 is sine 30, so sine 30 is 1 by 2. 1 by 2. So this 2 comes here and becomes into 2. So we can write from this. Next step we can write sine 60 plus delta m whole divided by 2 is equal to, not all this angle, within angle divided by 2 is equal to root 3. This 2 comes here and divides here, then it becomes root 3 by 2. So for this further can be expressed as 60 plus delta m by 2. That means that angle part is equal to sine inverse of 3 by 2. So sine inverse of root 3 by 2 gives 60 degree. Sine 60 degree is root 3 by 2, 60 degree. So here this 60 degree plus delta m by 2 is equal to 60 degree. This, from this we can say, this implies 60 by if you send this 2 here, it becomes 120. 60 plus delta m is 120. Delta m is 120 minus 60. It is equal to 60. This implies delta m minimum angle is equal to, also equal to 60 degree. So this is how you have to work out this kind of questions, guys. Got it? So note down this. Note down this quickly. Note down this quickly. Right. Right. Next. Next. Question number 22 is another track on 23. Next, let us see question number 23. Question number 23. So what is given here? It is just a concept based question, but let us see what is that. When a plane surface of a plano convex lens is silvered, then it behaves as. To understand that, you should remember that formula. We have discussed what the silvered lens formula. That you should remember and you have to apply here. What is that? When the plane surface of plano convex lens is silvered, then plane surface of plano convex lens is silvered, then it behaves as. Question number 23. When plane surface of a plano convex lens is silvered, this is a plano convex lens. When the plane surface is silvered, it behaves as what kind of lens? Or it behaves as kind of lens or mirror. If mirror, what kind of mirror? If lens, what kind of lens is the question. So we have discussed that this is equivalent to, when light incident here, first it refracts through this, then falls on the mirror, it reflects back and again refracts. So it is equivalent to sum of one lens plus a mirror, then again one more lens. What kind of lens? Same plano convex lens only. So it is equivalent to two plano convex lenses plus mirror. So the effective power of this combination is equal to, or silver plano convex lens is equal to power 2 times power of the lens, plano convex lens, plus power of the mirror. So here plain mirror will not have the bending power. Power is nothing but the power to bend the light rays. Okay, plane it will not have any, what do you call, radius of curvature. So power of the plane mirror is 0. So you can take it is equal to 2 into PL plus 0. And so equal to 2 into PL. So 2 into PL. PL is nothing but reciprocal of focal length. 1 by focal length of the lens, plano convex lens. So 2 into 1 by focal length of the plano convex lens from the lens maker's formula is mu minus 1 into, for plane of convex lens, 1 by r1 minus 1 by r2. R1 is r, r2 is for the plane surface. What is that? R2 is infinity, so 1 by infinity is 0, so we'll get 1 by r. So we'll get what is that? Effective power is equal to 2 into mu minus 1 by r. So usually for a given surface here, okay, we have to consider that for a refractive index, for a given lens will have some refractive index, so it is not given that it is surrounded by some medium, so it will be the refractive index of the material will be more than 1, so it will the total overall value will be positive value. It will be having positive value, means power should be positive. But it will behave like a mirror only. The light will comes back mirror only. So for which what kind of mirror? Because of this, it will not. It will bend. So it behaves like a spherical mirror with a positive power. Which spherical mirror will have positive power? The mirror, the spherical mirror which possesses positive power is nothing but concave mirror, because concave mirror possess positive power, so it behaves as concave mirror. We can conclude that, therefore it behaves as concave concave mirror. That is what you can conclude. Yet positive power, and of course it behaves as a spherical mirror. Positive power and spherical mirror. So we have concluded that that is nothing but concave mirror. Okay. So okay guys, is already time up. So we can see the remaining questions. Uh, we can see we'll see the remaining questions in the study hour. Okay. So I'm winding up now. So try to attend the study hour so that we can finish those questions in the study hour, and tomorrow we'll go ahead with the actual, what is that, schedule, and I will let you know what is tomorrow's I mean this coming upcoming week portion also. Okay then, everyone, take care. Bye bye. Hello guys. Hello. Hello guys. Are you getting the screen, guys? Are you getting the screen? Are you getting the screen, guys? Are you getting the screen? Are you getting the whiteboard now? Now I am sharing the whiteboard. Are you getting the whiteboard? There is some problem with. Are you getting the whiteboard now? Now I am sharing the streaming. Don't know how to resolve this. If any one of you. Don't know how to resolve this. If any one of you. Hello students, welcome back to the physics study hour. Because of some issues, we are having some problem here in streaming, but I think half of the screen is displaying and it is visible for you. I guess I think it is visible clearly. The remaining half is visible clearly, right? Yes, good evening. Good evening. Okay, students, we'll start now. Yes, no, half only visible. That's what this there is some issue actually, streaming issue. Uh, Something went terribly wrong. Uh, right now, I have no idea how to resolve this. So for time being, let us go ahead. Later, we'll try to resolve this and we can work out properly. Fine. Yes. See, let me show you here the question. The next question. So question number 21 is completed, right? Question number 21 is completed. Surface of a plano convex lens is silver, then it behaves as okay. 23rd one also I think we have discussed. Hmm? Then 20, right, right. Next 25th. When white light passes through a hollow prism, then what happens? When the white light passes through a hollow prism, what happens? So we still have to just remember that the dispersion and deviation conditions when light passes through a prism. Actually, when light passes through prism, dispersion will take place. Dispersion will take place. If you consider a prism, so question number 25, right? Through normally a prism, when light passes through a normal prism, right? It bends. If this is normal towards the normal, and it is traveling from rare to denser medium. Then here, if you consider another normal, when it is traveling from denser to rare medium, it bends away from normal, right? Whereas incident on the prism, different colors will experience different refractive indices, and hence they will deviate differently, and hence as a result, we come across a spectrum of colors, different spectrum of colors. You can say we call it as a dispersion, splitting of white light into seven different colors of passing through prism. When you get it, that we call it as dispersion. And if you have something like this, let me take a shape here. Yeah, if you consider just a second, guys. In such case, if light incident, if light incident on the prism, obviously if you white light incident here, it will split. It will what do you call it? Dispersion will take place. It split into different when it is traveling from rare to denser, it splits like this. Then when it is when they are traveling from denser to rarer, denser to rarer, how they will bend. If you draw a normal here, here we draw a normal. This will be the normal like this. Here this will be the normal. It bends instead of traveling like towards the normal, right? If it is coming out here, this sorry, this is normal, away from normal, it will bend. So and hence these rays, and when they're again traveling from rarer to denser, they will bend in such a way that if this is the incident direction, they will bend here again in such a way that like this, and while coming out, the light ray will come like this. It will instead of going in this direction, it will bend and it will come like this, so that we will observe the incident without deviation, and also we will not observe any dispersion also, no splitting also will observe if the white light passes through a hollow prism. This kind of phenomena will be observed when white light passes from white light passes through a hollow prism. So if you observe this question number 25, question number 25, you see here, there is I have to select the option appropriately. There is no dispersion and no deviation. Dispersion but no deviation. Deviation but no dispersion. There is dispersion and deviation. So we have observed that there is no dispersion and no deviation. There is no dispersion and no deviation. Got it? So this is what you have to observe. The next question number 27. Two small angled prisms A and B deviate blue rays by 7 degrees 9 degrees and red rays by 5 degrees 7 degrees respectively. Which prism has greater dispersive power? Which prism has greater dispersive power? Yes. What you can understand from this? Right? So note down what is given carefully. 27th one, right? Yeah, 27th. Two small angled prisms means thin prisms. We have to call them as thin prisms. Deviate blue rays by this. So deviation of blue ray by the first prism is 7 degrees by the blue ray by first prism. Deviation of blue ray by second prism is 9 degrees. Whereas the deviation of red rays for blue rays, first and second prisms are giving these deviations. For red rays, first and second prisms are giving 5 and 7. So for red rays, first prism is giving 5 degrees and second prism is giving 7 degrees. Which prism which prism has greater dispersive power? We know that dispersive power, I hope it is visible for you guys here. Dispersive power is nothing but ratio between angular dispersion and mean deviation. Angular dispersion is difference between the deviations of red and blue colors by that particular prism. For first prism, we take delta, nothing but sum of those deviations by 2. 7 and 9 are for blue deviation and 5 and 7 are for red deviation given by different prisms. 7, 9, 5, 7. Right. Question number 27, I think, right? So blue deviation for the first prism and for the second prism are 7 and 9, R1 divided by 2. So B1 minus R1, it is 7 minus 5, 2 by 7 plus 5, 7 plus 5, 12 by 2, 6, 2 by 6 is 1 by 3. For W1, W2, that is the dispersed power of second one is delta B2 minus delta R2 by delta B2 plus delta R is having more. Then next question number 29. Question number 29. It is given that the refractive index of the material of the prism for violet color is 1.69 and that for red color is 1.65. If the refractive index of the mean color is 1. Dispersive power in terms of refractive indices, right? Let us go down. Question number 29. So refractive indices are given. What is that? Refractive index for blue and refractive index of for red. Sorry, not deviations. Refractive indices. Mu, mu values. Mu for violet and red, not blue and red. For violet and red, right? For violet and for red, like see, refractive index. Refractive index mu for violet and mu for red given by the given prism, and this values are 1.69 and 1.65, 0.69 and 1.65. And for mean color, mean color they usually we call it as yellow color. Sorry, again mu for yellow color is given as I think it is 1.66, right? 1.66. Then what is the dispersive power? You should know dispersive power is nothing but delta for violet minus delta for red by delta for mean color. Fully here you can write it as a delta v plus delta r by 2, or for mean color, that is for deviation of mean color also, you can say directly deviation of mean color. And this you can also express this as, you can also express this as, this is equal to, yeah, here you can write omega, dispersive power omega is equal to, it is for smaller angles, thin prisms, it is nothing but mu minus 1 into a. So by using that you can write mu v minus mu r divided by, this will be mu v, y, mu of yellow minus 1. So here A's will be there, this A's and A's will be gets cancelled, then we'll get this one. By substituting these values, we get simplifying this, we get 0.06. So you can say dispersive power is equal to 0.06 will be the dispersive power. You can select the appropriate options. 0.06. For question number 29. For question number 29, 0.0 option. Second option. Then next question, question number 31. A plano convex lens of focal length 100 centimeters has a convex surface of radius of curvature 60 centimeters. The refractive index of the lens is, refractive index of the lens is, we have to use what is called focal length 100 centimeters, and what is this, radius of curvature? Radius of curvature 60 centimeters is given as different refractive index. Let us see how to do it. 31. Question number 31. This is question number 31. Question number 31. Yes, 31. So it is given that, what is given? Focal length f is equal to 100 centimeters, and okay, mu minus 1 is equal to r by f. So from this you can write mu is equal to r by f plus 1. Mu is equal to r by f plus 1. Mu is equal to r by f plus 1. So r is what? 60 centimeters, there in centimeters. F is 100 plus 1. So 160 by 100. 160 by 100. So it will becomes 1.6. So directly you can mention this as 1.6. So mu is equal to 1.6. So this is question number 31. 1.6, second option. So next 32, another one. Next 33. If you see question number 33. 33. So what it is mentioned here and what you are asked to find. So 33. It is mentioned that. Second, guys, one second. Weekend syllabus they have mentioned. Actually, I'll tell you the weekend syllabus. Tomorrow's during the class time, we will discuss about the weekend syllabus part. Okay. Okay, yes. That is received a message. I thought let's check it now. Let us go ahead. Let us go ahead. So, what is given here in the next one? What is that question number? 33, right? 31 done, 33. A thin converging lens of refractive index 1.5 has a focal power of say 5 diopter. Focal power of 5 diopter. When this lens is immersed in a liquid, it acts as a diverging lens of focal length 100 centimeters. Diverging means the concave lens. So focal length 100 centimeters means it will be negative. Okay, the refractive index of the liquid is. Okay, this kind of questions already we did. I hope you can do it. If anyone is having any confusion about this, just let me know. No need to spend again the time for extra additional time for working out this kind of questions. Next question number. So actually for this the answer should be um, 5 by 3. 5 by 3. Okay. Next question number 35. The angle of a thin prism is 4.5 degrees and refractive index is 1.52. What is that? The deviation produced by the prism is. So for thin prism, deviation is nothing but what? Delta equal to v minus 1 into a. Direct substitution, right? V minus 1 into a. So it will be 2.34. 2.34 degree. Direct formula only. Right? Next, 37. Under minimum deviation condition in a prism, if a ray is incident at an angle of 30 degrees, under minimum deviation, ray is incident at an angle means this is the angle of incidence, so angle of emergence also will be same, and the angle of refraction R1 should be equal to R2. That is the meaning of minimum deviation condition. You should immediately recollect back these points. Under minimum deviation condition, if a ray of light is incident at an angle of 30 degrees, the angle between the emergent ray and the second refracting surface of the prism is. So second refracting surface. What is first of all? We should know what is angle of what is the angle of emergence? Angle of emergence should be 30 degrees with respect to normal. With respect to normal. Here no need to even calculate. Here just simply with the help of one simple diagram you can understand this. So this is a prism. If a ray is incidenting here at an angle of 30 degrees, I is equal to 30. So it is refracting in such a way that in the minimum deviation condition, I will be equal to E angle of emergence. Angle, this is the emergent ray. Angle between normal and emergent ray is also 30 degrees. Also 30 degrees between normal and this. This is normal to the surface. Angle between normal and surface is 90. So 90 minus 30 will be the angle between the emergent ray and surface. So it is 90 minus 30 is 60. So it should be 60. It should be 60. That's it. Without any calculations, you can answer this. 60. Next question number 39. 39. So what is given here? It is given that a diverging meniscus means concave meniscus of 1.5 refractive index has a concave surface of radius 3 centimeters, concave surfaces of radii 3 centimeters and 4 centimeters. The position of the image if an object is placed at 12 centimeters in front of the lens is. Yes, this I think we have discussed already. So R1, R2s are given, mu is given. To find the position of the image, what is the position of the image? If the object is placed here, object distance is given. To find the image distance, you should find first focal length by using this mu R1, R2s by substituting in Lensmaker's formula. Okay, so according to Lensmaker's formula, I will give you a hint here, guys. Here only, just try for this one. First, find out f by using 1 by f is equal to mu minus 1 into 1 by r1 minus 1 by r2. 1 by r1 minus 1 by r2. R1, R2 values are given. Substitute these values with the sign. With the sign. Okay. So there have concave surfaces. This meniscus lens is nothing but it looks like this. This is the meaning of concave surface. Yeah, concave surfaces. Okay. So R1, R2. So both will be negative. So if this is negative, this is also negative, means this one will be negative here, another will be have a positive. Substitute the value of mu. Mu is also given refractive index. Then we will get F. So here 1 by F, and hence F F will be 1 by F is equal to minus 1 by 24, and hence F will be 1 by F is equal to minus 1 by 24. We will get 1 by F is equal to, this implies F is equal to minus 24 centimeters. Calculate this, everyone. Once you get F, by using Lens equation, 1 by F is equal to 1 by V minus 1 by U. U will be negative again. By substituting with the sign convention, you will get V. You will get V, the image distance as you will get image distance as, what is it? What the position of the image in front? If an object is placed 12 centimeters in front of the lens, in front of the lens means to the left side. So with the negative sign only you get. So it will be what is that? Minus 8 centimeters. Minus 8 centimeters will be the image distance. So here minus 8 we have, plus 8 we have. So this will be the answer. So first find out F by using Lensmaker's formula. Then by using the TF and U, find out B by proper sign conventions. That's it. Next, it is 39th one. Next, 41. Question number 41. So with image distance B, the focal length of the lens use rays. The focal length of the lens use rays. It is the graph of M versus V. The graph shows variation of magnification M produced by convex lens with image distance. Magnification with image distance is this. Magnification versus image distance is this. Magnification versus image distance is this. Okay. Now you have to just you have to understand that to find the focal length, because by using this by looking at the diagram, it is a straight line curve. So you have to write a straight line equation kind of relation, straight line equation kind of relation for magnification. So because you know magnification is nothing but V by U, V by U, by using lens equation. I will give you again here only briefly. Just you can go to the next separate page space and let us work out there. Let us see for question number 41. Question number 41. Yeah, let us see here. Question number 41. 41. Okay. So what is this? You have to take first one by lens equation. 1 by f is equal to 1 by v minus 1 by u. We have to, because it is given that magnification versus image distance v is a straight line if these values are given. Okay, to compare that, let us write this as in terms of magnification. To for that purpose we have to write this as in terms of v by u form. Here if you can write somehow v by u form if you want, v by this with v, then you can write v by u is equal to v by v by u is equal to this minus this r. So y equal to mx plus c form you have to write. Y will be nothing but magnification. So you can write this as something like, let us write it as, or let us do one thing, multiply throughout by with v, then we will get v by f is equal to v by v is 1 minus v by u. So let us bring this here, then it becomes v by u is nothing but m here. Okay, so I can write directly, this is 1 minus m. So bring it this as v by u, that is m, is equal to 1 minus v by f, 1 minus v by f. Correct? Or if you substitute with this sign, yeah, we have to just get here it is for, once again, magnification for lens or mirror it is mentioned. Then this graph is related to produced by convex lens. Okay. So on this values are given as a C and B also. I also have to keep in mind. Yeah. Now let's go ahead. So with sign conventions, usually for a lens, U will be negative and V will be positive. So if you can take it as with the positive, take this as with the signs if you take, you will get M is equal to V by F minus 1. M is equal to V by F minus 1 will get. Okay, so this if you compare with the here v is variable, f is a constant, so you can also write it as 1 by f into v minus 1. So if you compare this with the straight line equation, you can write it as what is that, mx plus c, as m is equal to 1 by f into v minus 1. This is a variable. If you compare this with the y is equal to mx plus c form, here this is here in this equation m is a slope we have in place of slope we have 1 by f. Slope is nothing but 1 by f. So in the graph, here only we are having the graph, right? This is a graph. In the graph, if you see, this is b and this is c. Slope is nothing but what is that? Change in vertical components by change in slope is equal to 1 by f. 1 by f, that is equal to b by c. From this you can say focal length is equal to c by b. Focal length will be equal to c by b. Accordingly, you have to take the option. So question number 41. C by B, C by B, not B by C, C by B. The fourth option is right. Fourth option is right. So next question number 43. Question number 43. It is mentioned that within liquid lens is formed in a glass for a refractive index of liquid is 4 by. Okay, if you have just not come across that, try to go to just listen carefully once. How to consider this combination of lenses. So simply, this is also by using what you call lens equation only. Lens equation. If you are having, if you are having the lens in air, liquid lens in air, you have to take. So remember this value. Within liquid convex lens formed in glass. Liquid lens is formed in glass. Okay, means surrounding medium will be glass medium. That is the meaning of it. Usually we consider usually just we consider a glass lens surrounded by air and a glass lens surrounded by some medium. But here lens material is nothing but liquid. Instead of glass, we are considering liquid. It is surrounded by air, then a liquid lens surrounded by glass. This kind of lens where conditions where you are taking that difference you have to understand. That's it, simple. Then by applying what you call a Lensmaker's formula, you can calculate it. So refractive index of liquid is 4 by 3 and that of glass is 3 by 2. Then if f is focal length of the liquid lens in air, focal length in the medium is, yes, let us see this now. Right, question number I think 43, right? So focal length of the lens in a medium, liquid lens in glass, right? So in glass, focal length in medium, that is glass medium, by focal length, actually let us do like this. When it is applied, what is that Lensmaker's formula? 1 by focal length of liquid lens in air, liquid lens we are talking about in air, is equal to the refractive index of a liquid, that is refractive index of the material of the lens. Material of the lens is liquid minus 1 into 1 by r1 minus 1 by r2, that is equation 1. Next, 1 by focal length of the lens in a medium. What medium? Glass medium. So it is equal to refractive index of the liquid with respect to glass minus 1 into 1 by r1 minus 1 by r2. You have to take this as equation 2. If you take the ratio of these two, 1 by 2 gives you 1 by 2 gives you fg by fa. Fg by fa is equal to, obviously it is ul minus 1 by ul by mu g minus 1. This two will gets cancelled. These two terms will gets cancelled out. So this directly I will give you the values. Mu l is given as 4 by 3 and mu mu g is given as 3 by 2. So on simplifying this, you will get you will get directly. I am giving you. You guys substitute and cross check these values. 1 by 3, and this will be minus 1 by 9. You will get this. You can write it as 1 by 3 minus, here 1 by 9 means 1 by 9. 9 goes here, so you will get minus 3. Fg by Fa is minus 3. Got it? That means Fg is equal to minus 3 into Fa, minus 3 times the focal length in air medium. So it will act less. So 43, 43. What is it? Concave. Diverging means concave with focal length 3. So option 4 is correct. Concave. Diverging means concave. Negative focal length, right? So concave with focal length 3f. That's it. So similarly, the 45th one. 45th one also based on the same procedure. If you see here, two plano-concave lenses. Two plano-concave lenses of glass of refractive index 1.5 have radii of curvatures 20 and 30 centimeters. They are placed in contact with curved surfaces towards each other, and the space between them is filled with the liquid of the focal length of the system. So it is a combination of three lenses. Focal length of combination of three lenses in contact. So you have to treat this like this. It is a plano convex lens. Another plano convex lens. This space is filled with liquid, so this will act like a concave lens. So you can consider this as a combination of three lenses. So 1 by effective focal length is equal to focal length of the first lens plus focal length of the second lens plus focal length of this liquid lens. F3 you can take it as. So 1 by F1. These two are similar ones. It has taken as. So 1 by F1, 1 by F plus 1 by F, it is 2 by F. This is a plus. You can take it as 2 by F1 plus 1 by F3 you can take. So the values are given here by applying what you call Lensmaker's formula. Find out these values and substitute. Then we'll get approximately 72. 72 will be the one. Actually it will behave like a diverging lens with focal length 70, focal length 72. So the focal length of the system will be 72, minus 72 actually. So we'll get a diverging behavior. That's it. This is briefly about the discussion part of all the questions, guys. If you want, just I will show you the other tracks key also. You can go through here once and note down for physics part. For physics part, note down this.